Your dog can lie to you. In the literal sense, choose between the truth and a lie and pick the lie. At the University of Zurich, a biologist named Marianne Heberlein tested this with 27 dogs and 3 boxes. The first box held a sausage, the second held dry kibble, the third was empty. 2 people worked with the dogs, and the dog's job was to lead one of them to a box. The first person was generous. Whatever they found, the dog got to eat. The second person kept the food. Every time. No exceptions. It took the dogs 1 day to figure out the setup. By the second day, they were confidently walking the generous person over to the sausage and the selfish one over to the empty box. Far more often than chance can explain. They didn't refuse to work, they didn't run off, they didn't growl, they calmly followed the command, and they sent one specific human to a box they knew was empty. Primates usually need far more attempts on tasks like this, and that's the bottom rung. Coming up, a cuttlefish that lies with 2 halves of its body at the same time, a bird that steals breakfast from meerkats and switches its method of deception the moment the old one stops working, and a chimpanzee who spent his mornings preparing a lie hours before he needed it. But before you believe the dog is lying, you have to decide what counts as a lie in the first place. Nature is packed with deception, and almost all of it runs without any intelligence at all. A cuckoo drops its egg into another bird's nest, and the forgery can be so precise that the hosts never spot the difference. There's no calculation behind it. For millions of years, cuckoo chicks with mismatched eggs got thrown out of the nest, and the matching ones survived. Time assembled this deception. The cuckoo simply carries the finished result. The same machinery can produce something much darker. On a summer night somewhere in Georgia, fireflies of the genus Photinus blink above the grass, and what looks like romantic lighting actually works like Morse code. The male throws his pattern of flashes into the air, the female answers after exactly the pause her species uses, and by the length of that pause, the two of them recognize each other. It's a password. In the 1960s, an entomologist named James Lloyd at the University of Florida noticed that some of the males were flying off toward an answer and never coming back. It turned out the answer was coming from a female of a completely different genus, Photurus. She had learned somebody else's code. The male lands on what he thinks is a mate, and she eats him. One of these females keeps the replies of 4 different species in her repertoire, and she picks whichever password matches whoever is flashing over the meadow that night. Lloyd counted it out. She usually needs about 10 answers before somebody takes the bait, and still, the same thing stands behind her as behind the cuckoo. Generation after generation, selection kept the females who guessed the other code a little more accurately than the rest. Now here's the case where that simple picture starts to crack. Off the coast of Australia lives a cuttlefish called Sepia plangon. In 2012, Culum Brown at Macquarie University described what the males do when a female and a rival end up on opposite sides of them. The male positions himself in between and switches on 2 different patterns at once. On the female's side, male courtship colors. On the rival's side, female colors. 1 animal, 1 second, 2 opposite versions of himself. The rival sees a harmless female beside him and stays out of it. The patterns themselves are innate. The moment he switches them on is another matter entirely. The trick showed up only in one specific lineup: him, her, and a competitor. And even then, only about 4 times out of 10. Change the lineup, and the cuttlefish never did it once. So the bar has to go up. We'll count something as a lie only when the animal does it right now, in this specific situation, with a full opportunity to be honest instead. For almost 100 years, science answered that nothing on this planet clears that bar, and it had a name it pointed to. In 1894, an English psychologist named Conway Lloyd Morgan wrote down a rule that would later carry his name. Don't explain behavior with a complex mental ability if a simple one will do the job. It's a sensible rule, but within a couple of decades it turned from a testing tool into a ban on the whole conversation. Any researcher who claimed an animal had understood something automatically ended up on the defensive. The first serious attempt to reopen the subject came in 1988 from Richard Byrne and Andrew Whiten at the University of St. Andrews. They mailed a questionnaire to 115 primatologists around the world with a single question. Have you ever seen a primate use an ordinary signal in a way that made another animal read it wrong and come out ahead because of it? 75 described cases came back. Baboons and chimpanzees accounted for the lion's share. Not a single one involved a lemur. The problem was that it stayed a stack of stories. Each one sounded convincing on its own. Together, they proved nothing. To move forward, they needed a lie you could catch in the wild, count, and repeat. The first one was caught in Kenya. The Topi antelope lives in the Masai Mara. Males hold small patches of ground and stand on them without moving. Females walk between the patches and choose. Topi have an alarm signal, a short, sharp snort. It means one thing: there's a predator nearby. The herd reacts instantly because the cost of a mistake here is lopsided. Better to freeze 100 times for nothing than to fail to freeze once. A biologist named Jacob Bro Jorgensen spent several seasons recording those snorts, and he found a pattern that makes you uncomfortable. The male gives the signal at the exact moment a female ready to mate turns and takes a step toward the edge of his territory. There's no predator. The recordings show the false snort is acoustically identical to the real one. The female freezes. The male gets another try. The signal is ordinary. Its meaning is ordinary. The entire lie rests on the moment he switches it on, and that moment is chosen perfectly. Further up the ladder sits a bird that took the same scheme to an industrial scale. The fork-tailed drongo lives in the Kalahari alongside meerkats, and it works as their lookout. It sits on a branch, spots a hawk before anybody else does, and calls. The meerkats drop their food and dive into a burrow. The arrangement is honest, and for years the drongo doesn't spoil it, which is exactly why they believe him. A British ornithologist named Tom Flower spent 847 hours in the Kalahari watching 64 drongos and logged 688 attempted thefts. The routine never changes. A meerkat pulls a scorpion out of the sand, the drongo screams hawk, the meerkat drops the catch and runs, the drongo takes the food. By the researchers' estimates, this bird gets about a quarter of all its calories through theft, and roughly half of those thefts run on a false alarm. It gets better. The drongo has 6 alarm calls of its own and 45 borrowed ones. It imitates the calls of other birds and mammals, including the meerkats themselves. 50 different ways to shout danger, and it rotates them. If a false call doesn't land and the meerkat holds on to its food, the drongo makes the next attempt in a different voice. The boy who cried wolf usually destroys himself. Lie 3 times and people stop believing you. The drongo found a way around that trap. It tracks whether the victim bought it, and it keeps swapping tools until it finds one that still works. So it's holding a model of somebody else's trust inside its head. But understanding what a victim believes is one thing. Understanding what a victim can see is something else. Who can do the second one? The western scrub jay caches food for later, hundreds of hiding places in a single season, and it regularly robs everybody else's. In 2001, Nicola Clayton and Nathan Emery at Cambridge ran an experiment that's still considered one of the most elegant in bird science. They let a jay hide food under 2 conditions: alone and in full view of another jay. Then they removed the observer and watched what the owner of the caches would do. Some of the birds came back, dug up everything they'd buried in front of a witness, and moved it all to new spots. After working alone, they re-hid a few percent of their caches. After being watched, a third or more. And here's the detail that matters. Only the birds that had robbed other caches themselves behaved this way. Jays without that experience left everything where it was, even with another bird staring straight at them. The jay was using its own biography as a model of somebody else's intentions. It knew what an observer was capable of, because it had been that observer. There was still a hole in the explanation, and it bothered researchers for 15 years. Maybe what sets the jay off is simply a pair of eyes in its field of view, with no thought about being watched at all. Eyes are a powerful stimulus all by themselves. In 2016, Thomas Bugniar in Vienna closed that hole. He worked with ravens, and he built a setup where there was physically nobody there to watch. Between 2 rooms, they put a wall with windows and 1 small peephole. First, they taught the ravens to use the peephole, walk up, look through, and see food being hidden in the room next door. The birds figured out what the hole was for. Then they sealed the windows, left the next room completely empty, and played a recording of another raven's voice. With the peephole open, the ravens hid their food fast, nervously, and walked away without looking back, the way they behave when they're definitely being watched. Close the peephole, and the same birds with the same recording worked calmly. There were no eyes anywhere in sight. There was a hole in a wall, and the knowledge that something could look through it. That sounds like proof. And this is where the skeptics enter the conversation, and their objection is uncomfortably good. To follow their logic, you have to look in on Berlin in the early 1900s. A math teacher named Wilhelm von Osten is showing the public a horse that can count. You give it a problem, it taps out the answer with a hoof, and it almost never gets one wrong. Crowds, newspapers, a commission of 13 people that finds nothing suspicious. In 1907, a psychologist named Oscar Funkst takes the case and runs one simple test. He asks a question in a way that leaves nobody in the room knowing the answer. Hans stops counting immediately. The horse was reading people. As the count approached the right number, whoever knew the answer shifted their posture a little, held their breath a little, lifted their head a little, and Hans stopped on that micro movement. Von Osten was cheating nobody. He had no idea he was cueing the horse. Clever Hans explains why the skeptics are so stubborn. An animal can produce a flawless result while solving a completely different problem from the one you credited it with. Now apply that to the jay. Picture a bird that got robbed a couple of times. One learned rule is enough for it. When another bird was around, the food disappears later. The rule fires. The bird rehides. No theory about another mind is required anywhere. Same behavior, nothing inside. This is what people call deception without a deceiver. From the outside, it looks like cunning. On the inside, it's associative learning, the same machinery that sends a dog running to the door at the sound of keys. Cecilia Hayes at Oxford spent years working out a careful version of this position. She never claims animals are stupid. Her point is that the simple explanation can't be crowned the winner automatically. It has to be tested alongside the complex one. And in almost every famous case of animal deception, nobody has managed to rule it out yet. Daniel Pavanelli adds an even more uncomfortable thought. What we take for reading another mind may turn out to be very good reading of another body. The animal tracks regularities in movement, and that's enough to predict arrival just as accurately, with no understanding involved at all. And the argument has a boundary science still hasn't crossed. You can't ask a raven. No language, no self-report. Whatever you measure, you're measuring behavior, and the question is about the contents of a head. So researchers went looking for one specific thing, something associative learning shouldn't be able to produce. To lie for real, understanding that somebody can't see you isn't enough. You need three things at once: that the other person has a picture of the world inside their head, that the picture can come apart from reality, and that you're able to put a picture in there yourself. Human children assemble that structure around the age of 4, and there's a classic task for testing it. Sally puts a marble in a basket and leaves the room. Anne moves the marble into a box. Sally comes back. Where will she look? A 3-year-old says in the box, which is where the marble actually is. A 4-year-old says in the basket, which is where Sally thinks it is. The child has learned to hold somebody else's mistake in mind. In 2016, Christopher Crupeñe and 4 colleagues staged that same story for great apes. Chimpanzees, bonobos, and orangutans watched a short video. A man sees an object hidden in one of 2 boxes, then walks away. While he's gone, the object gets moved. The man comes back. You can't ask an ape, so its eyes answered for it. An eye tracker caught where it looked a fraction of a second before the man moved. All 3 species looked at the empty box, the one where the object had been sitting when the man walked out. The apes knew perfectly well where it was now, and they still built their prediction on somebody else's wrong picture. The caveat here is an honest one. This understanding is implicit, and it's still disputed. Hayes again points out that anticipatory looking can come from simpler mechanisms of attention, but even if you accept the result whole, it's only half the job. An ape can hold somebody else's false belief in mind. It hasn't yet shown that it can put one there on purpose. For that, you need somebody who plans a lie in advance. Science has one. Exactly one. A small zoo called Furuvik in Sweden. A chimpanzee named Santino lives on an island surrounded by a water-filled moat, and since 1997, he's had a reputation. He throws rocks at visitors. There are plenty of rock-throwing chimpanzees in the world. Santino got attention because he did it on a schedule that didn't add up. Matthias Osvath from Lund University started coming in the mornings, before opening time. The zoo is empty. There isn't a visitor in sight. Santino is completely calm with no sign of agitation, and in that calm state, he methodically walks the shoreline, fishes rocks out of the water, and stacks them in tidy piles on exactly the side of the island where people will arrive a few hours later. Sometimes he taps along the concrete wall, breaks off chunks, and manufactures the ammunition himself. He's preparing weapons for a rage he doesn't currently feel. A few years later, Santino took the next step. Osvath and a colleague found and documented 35 hidden projectiles, 15 under piles of hay, 18 behind logs, 2 behind a rock. Santino carried the hay over himself and set it down exactly where the crowd comes closest. Then he'd sit down beside it, a calm, bored, uninterested chimpanzee next to a pile of hay. And when a group came within range, he'd throw without a single warning. That part is the heart of the whole story. A chimpanzee always announces an attack with his body. He rises onto his feet, his hair stands up, the screaming starts, the rocking, the slapping of the ground. Their aggression display is loud and obvious because normally it needs to be. The opponent is supposed to get scared and leave without a fight. Santino switched that signal off. He suppressed his own display so the people at the railing would keep seeing a calm animal in front of them, right up until the moment it was too late. He hid the weapon. He hid the intention. And he held a convenient picture inside other people's heads for hours at a stretch. Osvath himself stayed away from big conclusions. His phrasing was short. This is one guy. This is a case study. Santino died in 2022. He was shot during an escape from his enclosure. He stood on the top rung of the ladder science has managed to measure. The ladder doesn't end at chimpanzees. In 2004, Richard Byrne teamed up with Nadia Corp to ask a question nobody had gotten around to. This is the same man who mailed out those questionnaires 16 years earlier. He took 18 primate species, counted how often each one used tactical deception, and matched it against brain anatomy. The result came out clean. What predicts the deception rate is the volume of the neocortex. That's the newer cortex, the part we use to model what's going on inside other minds. Group size showed no such link. Neither did overall brain size. The more of that tissue a species has for thinking about others, the more often it deceives them. The ability to lie grows out of the same material as the ability to understand. The two don't get handed out separately. And on that curve, you're standing higher than anybody. How much higher? A psychologist named Bella DePaulo at the University of Virginia handed people diaries and asked them to log every lie they told. It came to 1 or 2 a day, in about a quarter of all their conversations. Almost none of the participants considered their lies serious. Robert Feldman in Massachusetts sat strangers down to talk for 10 minutes and filmed the conversation. 60% lied at least once. The average was 2 or 3 lies in those 10 minutes. One person managed 12. Most of them were honestly surprised when they were shown the tape. And Kang Lee in Toronto went all the way down to the beginning to find out what age this switches on. At the age of 2, 30% of children lie. At 3, half of them. At 4, more than 80%. Nobody teaches this. It arrives on schedule, like baby teeth. And the children who start lying earlier than the rest do better on tests of understanding other minds. Lying arrives on the day a child first understands that you have your own picture of the world inside your head, and that it can be redrawn. Psychologists treat that day as a milestone of normal development. There's one step you've taken further than anything else on this planet. William von Hippel and Robert Trivers assembled the evidence that humans are the only species that learn to lie to themselves, and the reason is extremely practical. Somebody who believes their own lie never gives themselves away. No strain in the voice, no hesitation, no guilty eyes. The best lying is produced by a head that has no idea it's lying. Speaking of guilty eyes, Alexandra Horowitz at Barnard College tested that exact face a dog makes next to a shredded pillow. It turns out the face comes from your tone of voice. Dogs that had done nothing at all put on the same guilty look the moment their owner scolded them. So the dog by the door never confessed to anything. He was reading you in real time and adjusting his face to match what he saw on yours. He was taking the first step up the same ladder you climbed at the age of 4. And you're standing on the top rung.